Okay, class, today we're going to be starting Chapter 8. The first lesson is going to be Chapter 8-2, the area of parallelograms and triangles. One of the words that's going to be very important in Chapter 8 is the word height. Height in geometry refers to the perpendicular distance from one base to the other in a polygon. If you look at the diagram, you will note that the height is going to be this dashed line that connects the two parallel sides. Now you'll notice that right here you have that right angle and it kind of looks like a chair. And I always tell students to look for that. Look for that dashed line and then that right angle. In this case it does look like a chair. And the chair sits on the floor, which is your base. The formula for the parallelogram is going to be area equals base times height. Let's look at our first example here. Whenever we are working with formulas, whether it's in math or in science, the first thing we should be doing is put down that formula. Area, in this case, area equals base times height. We do not know the area. That is going to remain the variable. B stands for base, which I do know, so I will substitute in the 25. H stands for height, which in this case is that perpendicular vertical dashed line of 15. No doubt, I would probably put this into a calculator, and I would get 375, and I'm going to have a label of centimeters squared. Area, by definition, usually refers to the square units that a polygon covers. We are taking a centimeter times a centimeter, so our exponent has to be squared. In example B, sometimes the height is on the outside of the polygon. So we're looking for that dashed line and that right angle symbol down here, which I've circled. Now, we use the same formula, area equals base times height. Again, we don't know area. Our base is 9. Our height is 15. 9 times 15 is going to give us an area of 135 square inches. For example C, I would like for you to hit pause. You do the problem, and then restart, and I'll show you how it should be done. So hopefully you got this one correct. Yes, I've used the formula, the substitution, the answer, the label. Again, remember area means meters squared in this instance. The next polygon we're going to be working with is a parallelogram. It's based on a parallelogram, excuse me. It's called a triangle. If you actually have a parallelogram and divide it in half by drawing a diagonal from one vertex to another vertex, you divide the parallelogram into two triangles. So the area of one of the triangles is going to be half the area of the parallelogram, which is why the formula for a triangle looks so similar to the area of a parallelogram. We are going to take 1/2 the base times the height. If we look at our first example here, yes, I look for that right angle symbol down in there, and the height is 12, the base is 36. In this situation, don't forget your formula, 1/2 BH, 1/2, my base here is 36, my height is 12. Now, I have to be very careful. I can only take half of one of those numbers. I can either take half of the 36 or I can take half of the 12. In this case, I would probably take half of the 12 because then I could do the problem with paper, pencil, or mental math. Yes, you could take half of 36 and then take 18 times 12, but even for me, that's going to be a longer paper pencil problem, and some of you would probably grab a calculator. So I'm going to take half of the 12 and get a 6. Okay, 6 times 6 times 6 is 36. I'm going to carry a 3. 6 times 3 is 18, plus 3 is 21. My label here is millimeters, and it's going to be millimeters squared. Now, notice, again, that you're going to have that height making a right angle. Also, what would have happened if this would have been a height of 11 and a base of 35? I probably would have used a calculator and put 0.5 times 35 times 11 into my calculator. Let's look at example B. Sometimes they don't give you the height as a dashed line, because in this particular instance, I have a right triangle. And in a right triangle, as I've noted on your note packet, the legs of the right triangle themselves, or of the right angle, become the base and the height. So it's the same formula, 1/2 BH. But in this instance, I'm going to take the 24 as my base, simply because it's horizontal and I have a tendency to do that, and the 18 as a height. Now here again, you could take half of the 24 and get 12, and 12 times 18, but I'm going to take half of 18 and get 9, and now I can do the problem paper pencil. I can take 9 times 4 and get 36, carry a 3, 9 times 2 is 18 plus 3 is 21. So I have 216 inches squared. At this point, please hit pause and you try example C. So how'd you do, class? Did you get the formula down? Substitute? Yes, you could have taken half of 30 and taken 15 times 20, but I chose to take half of 20 to get 10 because multiplying 30 times 10 is so much easier for me than even taking 15 times 20. Again, hit pause and you try example D. Okay, this one's a little tougher because I can't take half of 27 or half of 21 and get something nice and neat to work with. In this case, what I would do is in my calculator, I would put 0.5 times 27 times 21 equals, and you should have gotten 283.5. And that concludes our Chapter 8.2 lesson. Please reply with the word polygons. Catch you next time.